Yeah, thanks everyone for joining this evening. Like I said, especially on such a lovely sunny evening. Welcome to our Unity Developer Meetup. So my name's Jake. I'm the head of TA here at Product Madness. We're a mobile studio based in London. Don't worry, I'm not going to do a sales pitch. That's all I'm going to tell you about us. But we're really, really happy to have you with us today. We've got two amazing speakers with us. We're going to start with Nick McBroom. He's a lead developer here at Product Madness, working on one of our top titles. And then after that, we'll have Dino Dini, who is a lead programmer at Bosses Studios, but you've probably heard of him from, before from the amazing games they produced back in the 80s and 90s. Player Manager series, Kickoff series, Dino Dini Soccer, or Atari ST, Mega Drive, SNES. So you've really worked on so many platforms. So really excited to have you here. Thanks for joining us as well. Yeah, if you have any questions during this talk, we do have a Q&A box at the bottom. You'll see that. Now, please do pop any questions you have. We'd love to hear from you. The feedback we got from a session we did previously was that we didn't leave enough time for questions. So we've addressed that. There will be enough time for questions. There'll be at least 10 minutes after each talk. So ask away with your questions. Once the talks are finished, we'll get to those questions. We'll read them out and we'll get those answered. Sorry, neighbours just fired up their bike. Perfect timing. Yeah, we'll get those questions answered. And without further ado, Nick, let's begin. I'll let you go. Me and Dino will get out of your way.
Cool. All right. Hello. 1 second. Can you see that? All good? Right. Okay. So welcome to my
talk. We can see it. All good. Sorry. We can see it.
No worries. Cool. Right. So Konkansa, rumors them spreading. This is my talk. Konkansa, what it means, Konkansa is actually tree. It's a language from Ghana, and it's the most common language spoken there, apart from English. And it means gossip. It can be used as a noun or a verb. And it can also be used as an insult to describe somebody as well. The reason why I sort of brought this up will be understandable sort of later on in the talk. The subtitles, rumors them spreading, that's also a reference to one of my favorite songs. It's Gregory Isaac's Rumors. Please go listen to it. Great, one of the greatest songs in the world. But yeah. And before we start, public service announcement, in light of the current times and the unprecedented times as well, everyone be excellent to each other. And party on. So rumors, what are rumors? Rumors are generally, as you see, unproven expositions or interpretations of news. So things like fake news and things like that, purely because they're always unconfirmed. So we never know whether they're true, we never know whether they're false. And there's been quite a few case studies to sort of analyze how these spread, how they propagate, and what we can do to combat these. A good example is during the Fukushima disaster in Japan, Chinese public began panic buying iodized salt. They thought that that would basically protect them from radiation, and also because all of the radioactive material ended up in the sea, they thought that the sea was now also radioactive, and salt that you would buy in the stores was not actually safe for consumption. Of course, businesses and supermarkets took advantage of that, and they also raised their prices, which led to quite a few major public disturbances. And of course, in these times, that seems quite familiar. We've got obviously during the pandemic, when we were announcing it, we had a lot of rumors about it, and most of those turned out to be false, but resulted in people panic buying food. Another thing is also Bitcoin. Rumors brought the price of that up, and then of course the price subsequently crashed. Now, so how do we really combat rumors? We combat rumors through a few ways. Things like fact checking, quarantining, and immunization. So immunization basically is doing things like discrediting people who are spreading these rumors, spreading anti-rumors to combat them as well. Fact checking, obviously things like Twitter. You've got sites like Snopes, PolitiFact, and Full Fact, who their primary purpose is to fact check rumors and try and combat the spread of them. And of course, quarantining, which is quite a popular one in some parts of the world, which, for example, imprisoning people spreading these rumors, or actually just killing them as well. So why am I talking about rumors? And is because of Conconsat, which is my library for modeling rumor spreads within a population. Now, the purpose of this library is actually for a game that I'm working on, which is actually heavily influenced by Zanxia, which is I guess, a genre of Chinese fantasy. And it basically has features of martial arts, magic, Western sort of medicine, Taoism, Buddhism, things like that. But rumors play a massive part in these stories. So generally you have the main character who will sort of spend his time sort of training, getting stronger and stronger, but he'll never talk about how strong he is and things like that, purely, and people will start spreading rumors about his strength, things that he's done. And, you know, generally it's so that the main character can stay safe and people won't attack him, give him time to grow and become stronger. But really and truly, it's for the benefit of the reader, and it's always really fun to see like arrogant people try and belittle the main character when you know that the main character is stronger. But yeah, so that's rumors do really play a big part in those. There's a nice quote from an arrogant master: "You're dressed as a pig, but you are really a tiger." So that's basically, you know, you're pretending to be weak, but you're really strong. Now, so how is rumor spread actually modeled? So there's quite a few different ways to model it, and there's quite a few papers. There's a list of 3 here, so when you check out the video afterwards, you can probably check these out. They're very, very math heavy, but really, really interesting stuff. And they're usually modeled based using epidemic models, purely because viral spread and rumor spread basically exhibit the exact same sort of characteristics. So that's also quite an interesting thing to see. So if you're interested in that kind of thing, hit me up after this, we can chat about it. So generally how it works, it's a nice little diagram here. So in these models, you generally have 3 different types of agents. You have the initial state of the agents, which is ignorant. So they don't know anything about a particular rumor. And you always then will have somebody who is the patient 0. That person is no longer ignorant. That person becomes a spreader. Now, that person now can become a super spreader, or just a spreader that turns and then doesn't want to spread it anymore. So what would happen is, in this algorithm, in these models, is we take into account that, and we have probabilities of an ignorant person turning into a spreader, a spreader turning into a stifler, so somebody who actively stops the rumor, or another type of stifler where they actually don't stop spreading it, but they just don't want to talk about it anymore because they got bored about it, or maybe they forgot it. And there's also another type where they're actively opposing that because they discovered that the rumor is false. So then they now will start spreading their own anti-rumor to combat that. So this is I've lost the word I was going to use, but don't worry, we'll continue. It's fine. The most important thing here to sort of see here is that there are actually really distinct states here, and there are really distinct transitions between those states as well. So this sort of brings me a bit further onto like my own implementation and how I implemented it. So basically what I could have done is, you know, taken the math from the papers, turned that into an algorithm, and, you know, run that algorithm and get some result, and then use that result to sort of determine how much of my population actually knows about this rumor, and that would be fine. But my implementation is a bit different from that. It's like I kind of wanted to explore it a bit in real time, and also I didn't really want to make it super complicated, so I just fake it generally. So incidents generally in the game, or incidents can happen, and those are generally stored in a central list. So once those incidents happen, they broadcast information about said incident. So that could be sight, sound, smell, taste, touch, whatever you want, whatever information you want to define. And each agent in Concordia basically will have sensors that are tuned to pick up these bits of information. So there are also rules which determine what type of information they can pick up and where they have to be. So things like sight distance, hearing distance, you can even go crazy, do Doppler effect or whatever. But once all of that information is then picked up, that's then gathered and formulated into a rumor. So the rumor is actually just a construct that contains just some of this information. So, and then that can then be used to generate whatever you want, like whatever text you want or whatever. That's down to your implementation. But the agent then can decide whether it should spread it and who it should spread it to based on its connections. State transitions between stifler, ignorant, spreader states, as we saw in the previous diagram. And this is also what determines whether they're going to spread it to and who they're going to spread it to. That's modeled using Markov chains. If you're familiar with Markov chains, cool. It's like they're really, really interesting, really, really cool. But if you're not familiar with those, they're mathematical systems that basically transition from one state to another state according to some rules and probabilities. And their defining characteristic is no matter how you arrive at a particular state, it doesn't affect how you're going to arrive at the next state. So it's actually quite a nice way to model this stifler, ignorant, spreader transitions, because it doesn't matter if you were ignorant, you can go directly to be a stifler because you're not interested in spreading rumors, or you can, you know, become a spreader, but then decide to immediately not spread it because maybe it's not as high priority as another rumor that you know about, or something like that. So connections between members of the population are modeled currently using an adjacency matrix. Now, adjacency matrix are basically just a matrix that a graph is now deconstructed into. So each of the nodes on that graph are one of the indexes on either side of the matrix, and the value that is stored for those indices is either 1 to determine a connection or 0 to determine not connected. Now, this implementation is actually quite good for a few reasons. It's very, very fast to look up in constant time. And adding new connections between people is also constant time as well. Now, unfortunately, it also has a bit few downsides, but it was good enough for my initial sort of prototype implementation. Is that it uses storage to the order of n squared. So basically, for the amount of nodes you have, you need a square of that storage for storage, and also the time it takes to add or remove more nodes to it. So in other words, in this scenario, it'd be more people to the population is also n squared. So that's something that you need you should definitely be considered. And also as a optimization, that will be something I'll be looking at into a bit later. One of the other ways you could actually represent this, because adjacency matrices are really good for when you have really dense graphs. So really a lot of connections between all the different nodes. But when they're sparse, when you don't have, then basically your matrix is full of zeros, which is kind of pointless to have. So you can optimize and change into something called an adjacency list, which only stores a list for each node, determining which nodes they're connected to, which obviously uses less storage, but it basically brings other complications into implementation. now, concern uses. So generally, uses for this is at least going forward anyway, would be things for like procedural fiction. Basically, rumors can be logged, and because incidents are logged, and actually the people inside the simulation have no idea about the truth of these incidents since they're spreading rumors. Now, so those rumors can actually be stored and used to generate some fiction in your game. So it could be that they become, and if enough people have a rumor stored for them, that might become a legend or a myth or something like that. It can also be used for generating quests, like, for example, an incident may occur where a house was robbed, and rumors are spreading saying somebody has lost an item. Then you can generate a quest to say, hey, find that item for me, or something like that. Influencing AI, you could basically do that in the same way. That person, you now know who stole that item. So you can say something like, now we know that person has stolen that item. Now the rest of the AI can be influenced to go and attack that person to retrieve that item or something like that. But I think for me, the most interesting thing and sort of the main focus for me is information brokerage, in the sense of assigning values to pieces of information based on how true or how false they are, and also being able to influence this graph and of rumors with currency and things like that. And I think that basically brings quite interesting consequences to your games and the simulations. And so why is this in a Unity talk? Well, this is actually probably the most tenuously linked Unity talk you've ever seen, because the only reason it's linked is because this library is being implemented for my game, which is built in Unity. And that's basically it. And that's it.
Awesome. Thanks so much, Nick.
Thank you.
I really enjoyed that. You've got a really cool style to how you present. I really liked it. And it's just really informative. And we do actually have a question. So anyone that has any other questions as well, please ask them now. There's a Q&A panel you'll see on the bottom of your screen. So any questions you have, pop them in now and I'll ask Nick. But I have the first one, which is from Azaz. And it's, as a master's graduate who learned Unity for 3 to 4 years, how do I get a job as a Unity C# programmer without any prior related experience? So I can weigh in a little bit on that, but I thought I'd let you start. Do you have any pointers on that one at all?
Yeah, sure. So for me, I'd say probably the best way is to actually start build stuff for yourself. You know, it's like, I think that is probably the best thing. When I left university, I was, did the same thing, looking for jobs, and it was really sort of difficult to prove myself until I had, as I was building my own demos and building my own games and things like that, what I discovered was when I started going to interviews, I had more things to talk about, than just what I knew in books.
Yeah.
And actually building things myself actually made me realize that a lot of the stuff I learned in books were actually not really practical, especially for making games. So I was able to sort of, talk to people about things I'm making, things that I would like to do. And I think that was that's probably the best advice I can give. It's just build as much as you can.
I mean, the VC, so obviously I work in the TA teams of recruitment, talent acquisition. And when I'd worked with graduate schemes in the past, you'd receive quite a high volume sometimes, but the applications that stood out are people that had done their own work in their own time and had a portfolio they could show, like, oh, I've played around with this piece of software, I've tried this shader, I've tried to make this game, who had a portfolio to show. That was really, really important. We found that the devs in the team would really like to see that, those examples of work. And a lot of that is not actually having to have work experience. That does really help. But I think it's kind of the university's job as well to actually provide their students with opportunities to have kind of work experience at studios, because there's a lot of studios out there that are really happy to kind of give that work experience. So that does help, having any exposure, even a few months working at a studio in an internship. That's really good. And But yeah, having your own work, that seems to be really big. You know, having a portfolio, it doesn't have to be, it doesn't matter how kind of clean the code is or what it is, just showing that you're trying kind of different things in your own games. I think that kind of really stands out as well. So we have some more questions. Next one is, hi Nick, is it possible to have rumors mutate?
Can you clarify what you mean by mutate? As in, you mean change and...
So that's from Edward. Edward, I don't know if you could pop in the chat, if you could give us a bit more info.
I mean, if you mean by actually the data that's stored, right now, data that's the rumors that are stored, no, they don't mutate, but they do. There can be duplicates in that, if that makes sense. So multiple agents can basically have the same information for that rumor, and then that rumor can then be interpreted in different ways. Eventually, one of the next things on my list of things to do is to have the rumor sort of be affected by the actual agents, I guess, allegiances, I guess is the way to put it. But you know, so basically things about that particular agent will influence that that rumor. So in the sense, as I spoke earlier about it, saying that information brokerage was kind of the way that I want to go with this. It's like then if that sort of brings in things like bribery or some sort of allegiance to another faction that will cause you to falsify a rumor specifically. So, you know, you might not want to spread a rumor that's about your office because it's your office, but you might be happy to spread one about Microsoft because it's Microsoft. You know, that's I think hopefully that answers what you mean, but I'm not sure.
Awesome. No, thank you. We have a few more. So next one is from Tomo. Thanks, Tomo. Do you think that using a Monte Carlo style method of simulation rather than modeling the mathematical formula leads to more interesting results in a game? I get that the mathematical model manifested as a simplification for what actually happens in real life. Have I read that correctly? Yeah. I get that a mathematical model manifested as a simplification for what actually happens in real life. Might need clarification on the last line.
Yeah. Right. Okay. Yeah. I get what you're saying. Sorry, it took a while for me to pass that.
Okay. Yes.
Yeah. Yeah. So I think, you know, as with everything with games, generally realism isn't really what you want. You know, when you want something, so when you sort of model something in a kind of realistic way, you end up with realistic values, which might end up being absolutely nothing because it's realistic. But you know, in the purposes of the game, you want interesting things to happen. You want to kind of filter out the things that you know, not so great, and you don't want to sort of have nothing really happening. So I think, yeah, modeling it with that kind of simulation does make it a bit more interesting.
Cool. Next up, we have got quite a few in now, so I'm going to keep you busy. From Stephen, we have, thanks for the talk. One thing that springs to mind is how hard it is to bug check your implementation. Should an AI have that info, or is there a leak? How do you deal with those sorts of issues?
That's a really good question. Tests is one, but generally, I generally play it a lot, but yeah, it's one of those things. It's especially with AI as well. It's really hard to bug check. But basically, with my library as it is, that library itself is just C# by itself. So that is covered with tests, and that's okay. But the Unity part is I have no play mode tests for it, but I should probably add some more just to actually give myself a bit more confidence in that part of the implementation. But if anybody has any other suggestions, please give me some. Thank you.
Oh, no, yeah, but certainly put those in the chat as well. Thanks, Nick. Next one is, thank you for the presentation. It's very informative and interesting. I have a question regarding rumor generation. How would you define a rumorable accident within a video game? Incident? The incidents.
Okay, cool. So in the context of Unity, I actually basically have a just an incident is actually just a struct. And so my mono behaviors will fill that struct when things happen. So like when I create explosions, or when actual things happen in my game, we generate these structs, and they're just instants. And it's basically a case of who the actors, what actors were involved in that incident, and any other information that is relevant to that particular incident. So in the case of an explosion, which was actually my test thing, it was the sound that was played, so the smell, burning, and sights, so explosion. And so that information is basically put into a struct. So that's the incident. And then the agents that are around sense that struct, but they only can actually read the information that was picked up by the relevant sensors.
Oh, then we have Edward saying thank you for answering the question. So Richard asks, what sort of design challenges did you encounter during development, and how did you overcome them?
Nice question. So, okay, so the first real design challenge was really whether to do the mathematical way or not. And actually, when I first started building it, I was implementing the mathematical formula verbatim. So basically, my problem there was a case of, now I have this formula that sort of defines at a certain point in time how many people have this rumor or know about a particular rumor. The question is how to actually make this feel real in a game, right? So in a case where you maybe walk into a city with a population of 100 people, you calculate this, you pass that information into the algorithm, and then you work out that, okay, 75 people know about the rumor. Of those people, 15 of them are actually stiflers, and the rest of them are spreaders or anti-spreaders or whatever. But that doesn't actually feel, the problem there is now, which of these NPCs should have that information? How do I choose which ones of those that you would go and approach should know about it and which ones shouldn't? So especially when you want to sort of have your NPCs doing their own thing, walking around and doing other stuff, it makes it a bit difficult to actually model that accurate spread, because as you saw before, the adjacency graph, basically everybody is connected to somebody, but those connections, it doesn't really take into account whether that person can actually see that person or meet that person to spread that rumor. So basically rumor spreading became instantaneous with that algorithm, which was not what I was looking for. So being able to sort of use kind of Unity to kind of fake the proximities and things like that. So two agents near each other, some incident happened there, or two agents near an incident, something they now have that information. Then if they're near other people, they can spread that information. But if their contacts, anyone they're connected to, is nowhere near, then they can't spread it. I think that's them.
Cool. And one more question, last one. So hey Nick, what inspired the theme behind your project you presented?
Yeah, it's a couple of things actually. So as I said in the presentation, it's like I'm a big fan of Zanxia, so that's Chinese fantasy, and that is a big part of the sort of the world, and the narrative is rumors being spread, and but the real sort of inspiration was my auntie, because I took a trip to Ghana in January, and I actually don't really speak my native language that well. So, it's one of those things where my auntie makes fun of me all the time. And, so it's like I took it upon myself to sort of learn some more Twi. And I was talking to a girl, and she was like teaching me some Twi. And this was, Konkonsa was one of the words she taught me. And when I then went to speak to my auntie, and I was talking, and she was like, okay, so what have you learned now? I told her that, and she wouldn't stop laughing for about, well, actually she's still laughing about it now. So when I speak to her on the phone, that's what she says to me. So that sort of made it stick into my mind. And one day I was sort of as I was working on my game, I was sort of like, okay, what would be an interesting mechanic to kind of sort of bring into it, and that was it. You know.
Fantastic, thank you. And then Eugenio asked, I've missed the first part of the talk, where can I watch it again? Don't worry, we're going to record it, and it'll be on YouTube. I'm hoping to get it up tomorrow, but sometimes it takes a while to get it processed, so it'll certainly be early next week. We'll have a YouTube link, so you can all watch this as well again. But that looks like it's all the questions. Thanks so much, Nick. I really appreciate you kicking us off.
Awesome.
Really awesome talk.
Thanks for everyone for listening, and yeah. So if you want to chat about it, this is kind of stuff I'm interested in. Just reach out to me on Twitter, LinkedIn, and you know, Jake, or speak to Jake, and Jake will put you in touch with me as well.
Oh, sure. We should get your actually, what we'll do, we can, if you're happy, Nick, we can put your Twitter or whatever when we do the final post to everyone. Because I'll send you all a mail after this is complete with the link to the video, so we can put that there if you're happy, and ask more questions. But yeah, thanks so much. Really enjoyed that. It's awesome.
Cool.
Oh,
thanks.
You're free. Thank you. And Dino, you're up next. Are you still there?
Yes, I am.
Oh, brilliant. That's good. Hey.
Hello. Right. Well, that was very interesting. And this thing about rumors, I'll just go straight into it.
You can if you like.
Yeah.
So yeah, everyone, this is Dino Dini, so lead programmer at Boston Studios. I won't introduce you anymore. I'll let you do that, Dino, and I'll get out your way. Thank you, everyone, and please do continue to ask questions. It's really, thanks for being so engaging. It makes it, you know, it's so great that we can actually have these discussions. So thank you. Please continue to do that. And Dino, I'll get out your way. Thank you.
Thanks, Jake. And yeah, thank you very much for inviting me to talk. Haven't done a talk in a while. You can see from the photograph up there, that is the amount of extra beard from lockdown. So it's very interesting that previous talk there by Nick about rumors, which reminded me of this thing. You may recall that people have said that go-tos are evil or they're bad. And it turns out that Dijkstra never said that. What he was doing was making a case against the go-to statement. But in order to attract attention to this paper, the editor changed the title to go-tos considered bad or something like that, you know, and that has changed the face of the programming industry forever. So it's just like, you know, just one of those things, and that is sort of connected to what I'm going to be talking about. So let me just see if I can, first of all, share the right thing. Share it, because I'm going to talk about the survival of your project under Unity, and it does touch on this idea or concept that a lot of people replicate what has been done before without really thinking or considering whether, you know, just because everybody else does it make sense for you to do it. Anyway, I'll begin, hopefully. There we go. So me, my name is Dino Dini. That is my real name. I started making video games 40 years ago. I started in hexadecimal on an Acorn System 1. I've shipped many games over the years, starting with that, and migrated to C, then C++, and then just like everybody else, I got swept up in the whole object-oriented thing. And you know, some years ago, I started to claw my way out of that. I started working with Unity and C, well, not with Unity, the company, but with the Unity 3D about 10 years ago, and that's when I got into C#. I have pretty much ditched object-oriented programming, which I'll talk about a little bit, and then I am also increasingly cynical, which I think is normal, really short. While I'm giving this, if you want to ask questions or say anything, please feel free to immediately, and I will try to sort of work a little interactively. Anyway, currently I am lead developer lead engineer at Boston Studios, and we're working on I Am Fish, which is very exciting. You might be picking up a bit of noise from the street. There we go. Right. So Unity, the thing about Unity is it's great for starting projects. I mean, you know, it's invaluable as a prototyping tool, and I've used it an awful lot over the last 10 years in that context. You've got a lot of things provided for free or very affordable, and you have this promise of being able to deliver or build on multiple platforms, which is, yeah, it all sounds great. But there is a disadvantage that comes with it, and it's kind of like the counter to those things. One is that those rapid prototyping features are not really what you want when you're trying to ship a game, because as you get closer and closer to your deadline, what you're looking for is stability. And that's exactly the opposite of what you need at the beginning of a project. And so this has just raised its head time and time again as I've worked with Unity over the last 10 years. When you bring in technology from outside, you also bring in any technical debt that might have, which tends to sort of also exacerbate issues. And it was only a promise in the end that you'll be able to build for multiple platforms. I mean, essentially you can, but there's always a gotcha at the end. And especially if you're working on consoles, it's not really possible to just, you know, say, I want a PS4 version, boom. It doesn't quite work that way. So I'm going to talk a little bit about that. I have a question already. Is C++ important to learn and use as a programming language, since I already learned C#? It's a really good question. I'm going to give you a very quick answer to that one. Don't learn C++, learn C. But don't just dabble at C, learn C properly. And that will help you understand the underlying architecture of computers, which I always argue is very important for a programmer, you know. But okay. So the great shuttling, you know, the more people use Unity, the more opportunity there is for the company to monetize it, which is just natural. And they obviously, nothing wrong with that. They have to pay for all these people who develop the technology. But I do ask, what percentage of Unity projects are ever completed? That's a big question. Getting people to start has always been a lot more important than getting people to finish. You could almost say that's a problem throughout the whole industry. It's not just about Unity, but everything. If you go look at Steam, it's so easy to get your game on Steam. It's so easy to get your game on the you know, Apple Store. It's so easy to get started, but to actually make money, to earn a living, or just to ship a game, that seems to come sort of secondarily. And it's really down to, I would say, the gold rush idea. It's like the only people who really made money from the gold rush were the ones who were selling the tools or selling the shovels. So that might be an explanation as to why Unity has this focus. And I say it's not just Unity, it's kind of, it's a bit endemic in the whole thing. Object-oriented programming, okay. I bring this up because people get Unity not just to build games and hopefully ship them, but they also get Unity to learn how to program. So besides that question that was just asked just now, I'm saying go back to, you know, get the C programming language book by Kernighan and Ritchie and start there, because otherwise you're kind of missing out a lot. When you're working in Unity and in C# and you're looking at the solutions on the web that exist from a whole bunch of people, right? These are like rumors as well, you know? And this is exacerbated by the fact that, you know, academia does the same thing. And there's this bias towards object-oriented programming. And if I'm going to be completely honest, if you really want to be able to ship your game reliably and with minimal pain, you want to think very hard about doing something other than object-oriented programming as kind of like the mainstay of your architecture. It has its uses, and it's not something you would ditch 100%. But in my experience, to rely on it as the central piece of your architecture for your game is absolutely disastrous. And I know that eventually, I speak to other developers and so on, and eventually everybody kind of realizes this. I think maybe the industry as a whole is having a little bit of a wake-up call at the moment on this issue. So, you know, basically the languages and the tools and the frameworks and Unity itself actually shape thought. They are shaping the way we think about making games. Right? And I'm finding it pretty hard to think in verbs now. I always, what shall I name this? And it's like, I'm going to name it a noun. And I want to say, no, maybe there's something else. Maybe I should be able to talk about what my program does and not some kind of abstract and perhaps meaningless concepts about what it's composed of. So that's be reflected in some of the solutions that I'm going to show, which perhaps are, let's say, unconventional. And of course, now we have a data-orientated design has arrived, and you know, that's a wonderful thing. We can actually start to write like fluid simulations, or something I've been doing recently, write a fluid simulation in Unity without going into native code and have it run really fast. And this is, no complaints there. First compiler and the job system, and yeah, very, very good. But you can go to the other extreme with this. And, you know, one other aspect of this is this tendency, which I find disturbing, perhaps treating abstraction as being like a bad thing. As Dijkstra actually pointed out, abstraction is the primary tool that we use in order to write programs. Abstraction is the thing that we do as programmers. Figuring out good abstractions is really at the heart of programming, of good programming. So there is a danger, you know, that we're going to go the other way. We will see, because for me, really, what I want is reliable and stable game development. You know, I need to be able to ship my game. That is the #1 thing. And a lot of the focus on features and performance, it's important to a point, but you know, you don't have to have the maximum performance on every game that you ever make to make an entertaining and fun game. And what I want is to be able to ensure that I ship. It's risk management, essentially. So I always kind of, I hate the term vertical slice, I'll be honest with you. It's like the vertical slice. The problem with the vertical slice is that, you know, it doesn't stand up by its own. Underneath, to support that vertical slice, you need to have this huge horizontal slab. And if anybody ever produces a demo quickly, and actually seen this happen in the industry, you know, create a demo really quickly and everybody gets excited and they say, yeah, look at this, this is great. Oh, you're almost done. And what's missing is that it's just sort of hanging there and a little bit of wind and it's going to blow over. It's like, no, you need the foundation for what you do. And, you know, if I could say, I think that's one thing that we need to develop as in our industry more than we have, you know. So my focus is really on ways to make Unity, well, game development with Unity easier. And I think that if we can do that, then that gives us also more time to make better games as well, you know, and perhaps also have a less stressful time of it. Unity has been getting better at this. It's really noticeable over the last few years. So I may not be 100% up to date with the latest features that ease things, and that in itself is a problem with Unity as well. It's like a moving target. So advice #1, use a stable version of Unity. I can't stress this enough. You know, Unity 2019.4 LTS came out about 2 weeks ago. And now that that's come out, you should probably be using that if you're intending to develop in production mode. I mean, pre-production, if you're prototyping, yeah, it doesn't matter. But if you're actually going into production, you want to try and use a version of Unity that's not going to change under your feet. Really important. And things like HDRP, I Has a game actually been released with HDRP? Yes, it's an indie game. I can't remember what it's called. It really doesn't look like it needed HDRP, but it shipped with it. HDRP is allegedly production ready. Might not be a good idea to use it yet until there's been some time to do some more research on it. Advice number 2. I'm quite sure a lot of you already, well, maybe not do this one, but some of the other ones, yes. Put every application state into a different scene. Now, this creates some issues, but frankly, even if you're in your UI, if you have like 20 screens in your UI, why not make each one a level of its own, each one a scene of its own? And this means that each one of those is completely separate from the others, can be tested separately, can be set up separately, you can jump into it. You need to deal with issues like inter-scene communication, but I'm going to sort of deal with that. So really, I recommend that. So of all the different ways I've tried to deal with these things, that one's the one that for me has worked better than any other. Have a robust versioning system. Now, I'm not talking about source control specifically, and I'll cover that a bit. In this case, it's make sure that every build that you make has a unique identifier that you can see in the build itself. Really easy and really accessible, and you're really sure that anybody testing the game can verify which version they have. I cannot stress how important this is. It's so important, it's usually one of the first things I do. And maybe that's because I learned the lesson the hard way on the conversion of Goal to the Mega Drive, which was Dino Dini Soccer. After 7 or 8 weeks of intense work to port the core engine over to the Mega Drive, which involved all kinds of shenanigans, really delving into the hardware, and I had the thing running, and it was running at full speed with the graphics, everything, total proof of concept, and I had to send it off. And so what did I do? I burned the EEPROMs, yes, because this was a long time ago. We couldn't even use modems, it was be too slow. So, or maybe it was a modem, I don't know. I can't remember now. I remember these 2 EEPROMs, I still have them. Either they burned them or I burned them, I don't know. That's not the point. The point is that they went and reviewed it, and I got back this rather curt message. It says, well, we see that you've done some work, but there isn't really much to see on the screen, it's just blobs. And what had happened was there were 2 EEPROMs, and they had the one with the code, but the one with the graphics hadn't burned properly. And it's like, and I'm not there, I mean, because I was sort of in Cambridgeshire and they're in London, and I really learned, after that I put a checksum in before the game starts, it's going to make sure that it's integrity. And it's like, it always stuck with me. So make sure that everybody knows which version, so that when you say, yeah, I fixed this issue, and you're showing it to an executive, you're absolutely sure that the executive is seeing the one that you fixed, not someone that sort of happened before. Don't rely on manual steps for this. Very important. You need to make it automatic and part of your pipeline. So, you can use a timestamp, or I like to use the git, execute a git command to pull the hash of the current commit, and then write it to a file in screening assets. And then it's quite easy from there to display that within the application. And you make this all automatic, part of the build process, job done, never need to worry about it, allow time for testing that. Here's another favorite of mine, is use static classes as much as possible. Now, this goes against what a lot of people are taught. In fact, I hazard a guess that in academia, there really isn't anything said about static classes. The temptation or the view is always to create instances. And if you really want one, then create that awful thing called the singleton. Well, I take a different approach, and I would ask you to consider this approach. Every time you need to create a new class, why not make it a static class? Think about it. Can it be a static class? And if the answer is yes, make it a static class. Basically, if you need one of them, make it static. And figure out the rest around it. It's not so hard to figure it out around that. There are obviously exceptions. You can't do that with monobehaviors because you can't derive from monobehavior the static class. I will show a way sort of around that. So sometimes we're forced to use that horrible singleton pattern because of Unity's architecture. But there's this wonderful thing about using static classes. It means you never need to struggle to find anything ever again. You know, we don't have to have chains of references everywhere. Where is the screen? You know, where's the input? Where's input? You know, it just access them directly. Do not be afraid of doing that. I have some theories as to where this fear came from. I mean, globals are not bad, and this is something I talked about in my podcast. I call it a moth of programming. It's like a rumor that got out of control, and nobody understands why they say it anymore. Just consider, give it a go. Use dictionaries as much as possible. Now, dictionaries allow you to access things by name. Now, the value of that means that you don't have to have the compiler know in detail what everything is. So the great advantage of that is that you spend less time trying to fix compile errors. You have a greater flexibility in diagnostics. You have a greater flexibility in general. As far as diagnostics go, a very good debugging technique is to modify your code base. Say, take stuff out, add stuff, turn stuff off. When you have to turn stuff off by removing it from compilation, that is really quite painful. So if you can turn things off at runtime. And this idea of late binding, which you can also call it that, is not unusual. It was actually the central point of what object-oriented programming was supposed to be. If you talk to the person who was supposed to have started it, which is Alan Kay, states that above all, it's the late binding of all things. Make things connect together at runtime. Try and favor that. And one way of doing it is to use dictionaries. You can use dictionaries to link two modules together that, in a way that neither module is aware of the other. You know, if you've got these things here and these things, you need to associate them. You use a dictionary, so this has a key, the reference is one of these, and that's beautiful because there is now a relationship between the two and neither side is aware of the mechanism of how that happens. So there's a real level of abstraction. It is basically, there are only two things you really need in programming, it turns out, and that's dictionaries and lists. So almost everything I find these days I can solve by using those two things. So have a think about that. Consider using global storage. Though it's like if you need to store information on your application, I don't know, like the score, for example. You can have the score stored in some module somewhere and wrap it up and make it all objecty. But why not just have it as a global? You know? And if you have more than one score, let's say you have 4 players in your application or whatever, then these days what I'd be tempted to do is to create an array and make that array global. And then there are 4 scores. So that these things are still, you know, they're global, they're accessible from everywhere. One of the ways you can do this is by using key value dictionary. So it's like having an equivalent, like a Windows repository, right? Only trendier and inside your application. You don't have to do this for everything, but for things which are persistent and inter sort of module communication, there's a really strong argument for doing this. You can write tools to set and view these at runtime for diagnostics, which are can be really invaluable. Your data is available everywhere, and you can even set up automatic serialization of these things so that state can be remembered, you know, between runs, or you can serialize the state upon a crash or an exception. That gives you the ability to really, you know, after the event, examine what happened in detail Debuggers are great, but the debugger isn't really going to help you when somebody testing your game finds that it crashes on level 35 after they've been playing the game for 3.5 hours. You know, it's like, you've got to think, how can you, when that's, because it will happen, how can you deal with that? One way is to really manage your data in a kind of a more centralized and accessible way than perhaps you would get with object-oriented thinking. So along that line, we can go to another aspect, which is another thing, which is the noticeboard pattern. Now, the noticeboard pattern, I don't know if anybody else calls it this, but this is what I use. So I'm going to try and run it through it quickly. I was going to run out of time, I realize. I'm going to be careful. So what we have is a button with a thin mono behavior component on it, and then we've got a UI text to show something on the screen which has a thin mono behavior, and I'm going to show you the code for those in a minute. And there's this notice board. The notice board is just like, well, a notice board. You put notices up on it, and some people notice the notice, and people things. So it works like this. When I press the button on click, I put into the notice, which is called debug message, I put hello. Okay. Then what happens is that the UI text mono behavior thing there, it notices or is told, either way, by polling or by callback, can find out or be aware that that has changed, and when it's changed, it changes the text. So what we have here is a very simple thing. You press a button and hello appears in a text box, right? Now, if you think about the way that you might do that in other approaches, you might have the button and you might have the, the two components, the button and the box. You might generate an event from the button, and then you might send a message over to, and in Unity, you're going to link the two things together or select them from a drop-down menu for a function which is called, and there's this dependency which you set up in the inspector in Unity, and that's all very fragile. And the two objects are kind of aware of each other, and it causes a lot of issues. This, on the other hand, so the button, when the button is pressed, all it does is set the value of debug message in the notice board to hello, right? That's all it does. So I can make a very general purpose little component here where I put in the name of the key to write to and what to write in the key. Attach that to any button, and its job is done. The total functionality is put the notice on the notice board. Thank you. Then on this side, the UI text object has got a component, which is this text notice component, a thin mono behavior, and all it does is it's actually waiting to be notified by the notice board that the notice debug message has changed. And again, this can be done as a general, as a general purpose component, where in the inspector you put the name of the notice that you want to tie this to, and you can ask the notice board for a callback. That's what this on this notify is. When it changes, it will get notified, and it will magically change. There's no update function. There's no need. It's like a message, but it isn't a message. It's different to a message in some very important ways. The first one is there's temporal decoupling, which you can also get with messages. I mean, messages, if they're sort of stuck, put in a buffer somewhere. But temporal decoupling basically means the sending of the message and the receiving of the message do not have to happen at the same time. And although they may happen at the same time in this example, if I modified text notice here to poll instead, so that there's an update function that just keeps looking at debug message, then it's definitely not temporally coupled anymore. The message send, and message receive happened at different times. And that is, it turns out, is actually very good piece of decoupling or abstraction for a whole heap of reasons. I really don't have time to go into it, but the notifier also need not be concerned about who's interested in the notice. This is so important. It basically, the button doesn't care who's going to react to the message. Similarly, the receiver of the message doesn't care who sent it. So what you have is the button is a completely separate component, very simple and totally decoupled, as is the thing that displays. And I can tell you, you've been using this pattern in this form now for a few years, and it's absolutely invaluable. The level of decoupling that you get is brilliant, and means that down the line, when you get closer and closer to shipping, you will get fewer of those calamities where the build is broken and all the linkages have been messed up, and you have to sit there stitching your game back together again, which frankly is just the stuff from hell. So there you go. And a bit more about this. You can also add a custom editor window, which is something I do. So then I create a view of the notice board inside the editor in an editor window, which allows me both to view the notices and change them. So this allows me to test either the button side, in this case, or the display side, completely independently of each other, which for diagnostics is really invaluable. If the button doesn't work, the first question you have, is it because the button didn't register the press in some way? Or is it that, you know, for some reason the message is not being displayed? So having this thing in the middle that allows you to immediately decide which one of these two it is, really can't recommend it enough. The other thing you can do is also have automatic serialization of the notice board, which is useful for a bunch of reasons. But I better move on. Here's another one. Advice number 8. Embed networking, even if you're not working on a networked game, which might sound a little silly at first, but I quite like to embed web servers in games. So the last PS4 game that I shipped had a web server built into it in, you know, debug mode or development mode, which allowed me to pause the game, take screenshots, take snapshots of the input, get a dump of state, internal state. In fact, what would happen is that when I would get an assert, I would be able remotely from my PC to connect to the web server and just pull the data out that could be attached to the bug report that would then later allow me to recreate the bug by you know, virtue of the game being deterministic. So I could just replay the input, fast forward it to the point, and recreate the same bug that I just had. Very, very powerful stuff. But the point is, I don't even go into that in detail here, but the point is that all of this was achieved through a web browser. And that web browser, of course, web server, and that web server will, of course, also work on consoles. So I could actually do this from the PS4 as well. You know, very, very powerful. The other thing you could use it for remote logging. So you can send your logs over the network somewhere to a server, everybody playing your game. You can accumulate all of the logs, very valuable. You can put to that telemetry into bug reports, so that one. Proxies, and I'm going to say more about proxies in a minute, and very rapid development experiments I've also done with, you know, worked with, where Unity's a bit slow every time you hit play. I mean, 5 seconds. There are some things they've done to speed that up a little. But if you build some code in Visual Studio and you hit F5, and you can get that stuff built really quickly, like in a quarter of a second. So why not have it build, execute, connect over the network to something that you are working on that is displayed in Unity, and you can broker that way really fast iterative development, and you never hit without having to stop Unity and hit play all the time, which really slows things down. So things to consider. Depends on your game a lot of the time. Continuous integration, very important. Make sure you have a continuous integration system in place. Make sure it works on all of your branches. You know, don't just stick to one or two. And don't rely on Unity Cloud Build. I found that it's really, really slow, especially if you're working on consoles. You know, you can use GitLab, for example, which I'm just becoming acquainted with now, but that seems to be actually really good and has built-in CI, it's built-in a continuous integration. You want to catch problems that you create, especially when shipping on multiple platforms. You want to catch them early. You want to know the moment you've done something that later on will break the PS4 build. You want to know that as soon as possible, because to try and find it out, you know, a week later, that's hell. There's a whole thing you can do to solve that when it happens a week later, yes, but it's hell. You try and avoid it. Source control. Use Git or Mercurial. I used to use Mercurial. I preferred it to Git originally, but right now there's practically no difference between the two anymore as far as I can see. Okay. Distributed source control. You've got branching that's immediate. You don't have to lock down a branch and do a copy up or whatever that some versions of source control systems need. If you haven't moved to distributed source control, do it, please. 12, have a strict branching and integration process. I cannot stress this one enough either. You know, what you want to do is make sure that everybody's working on their own features and their own stuff in their own branches. And then you need someone, the integrator, whose job it is to pull the work of different people in. Don't have people integrating. In fact, don't have the same people who are developing code as much as you can avoid it. Don't have the same people who are developing code also integrating it. Right? So if you create a branch for integration, what you can do is pull from develop into integrate, then pull the work packages or the branches or whatever that's there, pull them into integrate branch, and you have a space for that process of integration as a development production process in its own right. Right? You just do it, please, 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 because one of the biggest problems I've seen over and over again is people underestimating the amount of time that we need to spend integrating. It's utterly and totally vital that we consider and take that into account in what we do. And if you have someone who has the role of the integrator, they're the ones who can do the integration, run the tests, make sure everything is sane before pushing that to develop. And then from develop, everybody else can pull the integrated stuff that you know, is sane, so that you don't start polluting everybody's workspaces with integration errors, so that integration errors become, you know, start feeding back on themselves. It's kind of a nightmare. And don't let your backlogs grow. Integrate frequently. You don't want to try and integrate 2 months worth of work, you know, into another team's 2 months worth of work. It's insane. Don't do that. Don't be afraid to derive from mono behavior. Now, this one is a little bit unusual maybe, but I do it, and I realized I had to be brave to do it, because everybody, you know, everybody works with these patterns, don't they? You see how people use Unity, and you follow it, and you say, am I allowed to do this? Yes, you're allowed to do this. I've created a mono behavior X and derived that from mono behavior, which means I can add functionality to mono behavior. In this case, giving me the ability to just say position instead of transform position, and rotation instead of transform rotation, and forward instead of transform forward, and so on and so on. Why? Well, because if your code is littered with the word transform everywhere, it makes it difficult to see what's going on. It's the signal to noise ratio is sort of poor, and you're typing transform all day, and it's pointless. In general, you should keep your mono behaviors small. You know, if they are small and well organized, give me one good reason. I just seen your question there. Sorry. Oh, it just came. So it's not there. Right. Why? Give me one good reason why we shouldn't do this. So I like to do this now, and it's lovely. I mean, it means you can bring back the good old days of Unity. Do you remember the time where you could just say rigid body? Now you didn't have to say get component rigid body. You could just say rigid body. Then what happened was that in the architecture of Unity, this created a problem, and I know what kind of problem it is. You end up with this huge mono behavior class that has to understand at a compile time every kind of component that it needs to deal with. Now I totally understand that, But here's the thing, you can bring that back. And so this is what I do with my mono behavior X. This is just continuing here. Oh, sorry, continuing. Is I have a rigid body cache set up here, which underscore rigid body. And then I create a property. And the property just checks to see if I have already collected the rigid body with a get component. If I haven't, I do. And it just returns that rigid body. So it means I can now say rigid body, and it works just like it used to. And it get to the cost of one if statement. And totally worth doing. And it will make your code cleaner and easier, less to go wrong. You're not distracted when you're there working on a rigid body that you have to suddenly jump from where you are up here to put in the definition, which is something that, you know, IntelliSense and all the tools we have for IDEs tends to make us do. I don't know about you, but I use Emacs these days. I got sick of it. So it's just, you can just say it and it's dealt with for everything, everywhere. Never have to worry about it again. Consider deriving from mono behavior. There's tons more stuff you can do that I've experimented with, which I don't have time to go into. But make a platform proxy. Now what this one is about is you want to build your game on a console. The game on the console wants to connect to the network services of that console. This is the case with PS4. You can't do that in the editor, so you have to make a build. But it takes an hour to make the build, or if you're unlucky, a day to make the build. You've got a problem with the code in communicating with the servers. You can't rely on the fast compile and test cycle of Unity. You have to make builds. You don't ship the game. So what you could do is be smart about it. I've actually recreated the majority of the PlayStation APIs for talking to the servers in a proxy that was able to communicate with Unity over a network, so that I could hit play and operate my UI that is integrated with the PlayStation services, right, from the editor to debug things. And I wish I had done that right at the start. I didn't. And as a result, it really cost me. So now it's like, that's a good, get the networking into your game, even if you don't need it. All right, so advice number 15, keep checking all the time for best practice, for new best practice. This is difficult because new things are happening in Unity all the time. But what I tend to do is if I go and say, you know, last time I had to deal with this, it kind of sucked. So let me just check, is there a new API? And you'd be surprised how often that is the case from the last time you checked, and then you can embrace that. So you need to, you know, don't just keep repeating what you did before. Minimize the reliance on the inspector. I kind of touched on this a little bit, you know. Like if you're tuning your game, you can tune it really rapidly by changing all these parameters and so on in the inspector. That's great, but it's very fragile. It's difficult to track in source control. So consider at some point switching to a mode where you store all of that information in some file, an ini file, domain-specific language file, like an ini file, or you know, data driving your game. And it's possible to do a hybrid approach as well. So that's something that I'm looking at the moment, is to have, you know, to have your cake and eat it on that one. Avoid scriptable objects, please. They're incredibly fragile. I've never really found them survive very well by the time you get into really heated production. It's because of the way that they're kind of linked to objects inside Unity. And also, if you know, I've tried to do things where you're driving the build process that is affected by scriptable objects. It's a nightmare. So in general, I just don't bother with them anymore. It's quite easy to just sort of read in a JSON file, frankly, and I don't really see why reading in a JSON file is any worse. If you have lots of data, think about using a database. Don't be worried when somebody comes over to you and says, are you sure that's not overkill? It's almost always not overkill to consider using an SQL server or something like that, especially if you're familiar with it. Learn Unix, really valuable one. Unix tools and the tool chain are incredibly powerful so that you can do amazing things in 30 seconds. There is a danger that comes with this, which is that sometimes people might think that you've been spending all day carefully placing hashes. I wish I was joking when I said that came up once. It can get you out of all kinds of sticky binds, especially when you're dealing with modifying assets. I've often used scripts where there was something that could only be changed by or fixed by modifying, 200 asset files and making a little edit to some YAMLs or whatever. And you can set up a script and use the sed editor and just, yeah. So try this. This can save your life. Sort out your get attributes file at the start. You really need to do that. Make sure you don't try to reintroduce LFS on files halfway through. Make sure that you do not auto-merge your asset prefab and Unity files, can corrupt your project in ways that can be very difficult to get out of. And always disable CRLF, line feed conversions, because that will drive you nuts. You just want source control not to mess with your files because it thinks it's a text file and it can change the line endings. Never assume Unity's code is correct. This here is the normalize function from Unity. There is this check. Basically, if the length of the vector is less than about 10 to minus 5 or 0.0001, whatever, then return 0. If you've ever taken a big model in Unity and shrunk it down and then found it turned black, the explanation is all the normals became 0. And the reason is this, because you might think that 100,000th of a unit is, who cares about that? But if you take, and this actually happened to me in a project, if you take a triangle that's about 1 millimeter in size and you try to calculate the normal by doing the cross product of two edges, in doing the cross product, you actually end up with the square of that distance. If that distance is 1 millimeter, you're already at 1,000th. You take the square, you're at 1 millionth. You've actually exceeded this. And it means that Unity is incapable, if you use the code that you think you should use, is incapable of calculating the normal of a triangle smaller than 1 millimeter because of this bug. And the problem is people deny that it's a bug, but it's a bug. And they don't fix the bug because imagine all the things that would be broken if they fix the bug. Persistent monobehavior pattern. I'm going to have time for questions, I think, nearly there. The persistent monobehavior pattern. You want to have objects which are persistent all the time across scenes. But the problem is that you're testing a scene. And so for testing that scene, you also want the object to be in the scene. How do you handle this? You want to be able to jump into the scene, but this manager class, it needs to be in the application as a whole. And so, okay, you can put it in multiple scenes, and that's what I do, but you don't want it to appear twice. And you want it to be accessible from everywhere, like the singleton sort of. So this is what I do, a very useful pattern. This underscore here is just the thing I use personally to indicate the single instance of a class. And on the awake, you just see, have we been initialized? If not, then I set that global instance, call it instance if you want, if you don't like the underscore. And then just don't destroy on load. So when the scenes change, it remains. And if it's already been initialized because you're loading in a scene that also has one of these, it just destroys itself. I've used this for a long time, very good pattern, never had problems with it. You never need to worry about this issue after that. Split scenes into prefabs. I'm sure lots of people do that, but it is worth mentioning. If you keep your prefabs, if you have scenes basically that go into the build that are almost never modified, and all that's modified are prefabs, the point is that those prefabs can be shared with staging scenes that are used in production. And that is so useful because let's say that an artist needs to, just for debugging purposes or just to help them, needs to add extra lights in the scene where they are rigging or building something. I mean, you don't need to worry about those ending up in your build because they will modify the prefab, they save the prefab, and now it goes into the game. It's a really very good approach. Don't overuse nested prefabs. It's really scary if one little prefab can be modified that causes a whole heap of changes everywhere. Make sure you really need a plugin before you bring it into your project. I have told people off for bringing in huge projects for doing easing, when the only kind of easing we needed was one that could be done with one line. You don't want bloat, you don't want to slow down your compile time, you don't want technical debt coming in. Don't just go grabbing frameworks and stuff. And finally, and probably the most important one of all, is always read your Stack Overflow pages from the bottom up. And that's it. Any questions? We've got one question already, which is, what are your thoughts on using functional programming techniques within Unity and C#? I think functional programming is something that you can create by, you can do functional style programming by just ensuring that you write functions that don't have side effects. Let me stop sharing. That don't have side effects. But in the end, you really need to have good state management. And I'm working on a programming language at the moment that sort of tries to rationalize these two things. But it's a bit of too big a topic to go into here. Jake.
Hello.
Hi. All okay?
Fantastic. Thank you so much. No, I really enjoyed that. It was awesome. And I've just asked everyone to pop in questions to say, yeah, any questions that you've got, now's your chance. Please do ask Dina. We do still have some time. Just so that we have another one that's come in.
Yeah.
You've probably seen.
It was good to check in with you, because I've just been sort of talking to. Oh. Yeah, it's weird doing it this way.
It's really unusual, isn't it?
There's no audience to look at.
Yeah, I know. Usually I find that as well. With usually you get to look, you see people and kind of interact as you go, but you're looking at your screen the whole time. You don't see anyone. It's really unusual.
Weird.
Thank you. No, we really appreciate it. Lots, so much energy in that. That's really awesome. And we've got more questions coming in, which is really good.
Okay. I'll great presentation. Cool beard. Thank you. I was wondering what the main aspect to make a successful game for people to keep playing it. Well, that's a really good question. I'll come back to you on that. I need to think about what I can say on that. Thank you for the presentation. I learned a lot from different programming topics. Really enjoyed it. I have a question regarding scriptable objects. I think if non-technical person needs to edit a file, they might be scared. Yeah, so this is the thing, is that very often the UIs that we add to our game development is designed to stop people being scared. I'm just going to come right out with it and saying we should just stop being scared. There is a trend of everybody being scared of almost doing anything. And so even programmers are becoming scared of programming. It's like, it's not that hard. You just need to calm down, not think that there's a magic solution. You can press a few buttons and it makes things happen. Let the programmer design how the language should work in conjunction with the designer, and you sit down and you calmly just work out how you can work together as a team. Programmers will figure out the detail of language, and designers and everybody else can work on expressing themselves, and we'll get on. So I'd just say, let's not be afraid anymore. But yes, it is a problem. Hey Dino, thank you. Are there any assets plugins from the asset store which you use very often? There used to be. There used to be, and I stopped using them. I'm trying to think if there's any that. Here's one example I used recently. I needed to do text to speech in a project because it was a lot more rapid than sort of recording scratch audio, and then I used a plugin for that. I've done a project where I needed to have a MIDI interface, like music MIDI interface. I used a plugin for that. So I tend to use them when they're really going to be a tough grind to figure out. If I want to use SQL, I might use SQLite inside the project, and I have used those plugin from there. But that tends to be the kinds of plugins, and the really good ones are the ones that have been incorporated into Unity now, so they're not really from the asset store anymore. That's is another trend. The Noticeboard example, would also use this to pass through objects and data, and you could use multiple notice boards. Yes, you can. And there's no reason why you can't have multiple notice boards, and you can make them support all kinds of types. So I agree. Well, that's it.
Well, does anyone else have anything else to add? Any other questions? Whilst we have both Nick and Dino here. No, I think that's everything. Thank you so much, Dino. I really appreciate your time that you gave us today and the sage advice you've given us. So our first one of these events we've run, but I've really enjoyed it, and I think it'd be great to kind of run these again. And we've all been pushed into this sort of online virtual format, but I actually think it works quite nicely. It means people don't have to sort of travel all the way to an office. We can have people from all over the world join us, and people can be in the comfort of their homes when we do this. So we're certainly going to look at doing this again. I'll send you all, as I said, the recording of this today. And also we'd love to hear your feedback as well. Any feedback you have about how we can kind of improve the format or anything that you'd like to see. But I just want to say a big thank you to you, Nick and Dino. Thanks so much for your time. It's really, really great. Thanks to everyone that's given your evening up. Yeah, I'd love to do this again. I think it'd be nice to do quarterly, but we'll get your, it'd be good to get all of your feedback, see what you think, and yeah, just thank you so much, and have a fantastic evening. It's been really awesome.
And you and everybody, thank you.
Yeah, cool. Thanks for listening, guys.
Yeah, thank you both, and yeah, everyone have a lovely evening. Enjoy the sun. It's still really nice and warm outside, and yeah, we'll speak to you all hopefully soon. We'll run another one soon.
Okay.
So thanks a lot. Bye, everyone.